Hey, I'm Taylor Dorsett, and this is the Professional Technical Interviewee. Technical interviews are hard, and every company does them differently. On this show, I interview engineering leaders to see what they look for in technical candidates, and then they perform a real technical interview with me.
My guest today is Patrick Miller. We talk about his journey from individual contributor to director of engineering and back, and what he looks for when he hires for engineers for his team. I hope you enjoy.
All right, and we are back. Patrick, the ball's in your court now. I'm in the hot seat. Let's get into it.
Sure. So as I alluded to in that previous segment, what I used to do on technical phone screens was give this problem to people. You can use whatever language you want. The idea is I'm going to give you an array of data. The array is always integers. They're always positive integers. And there's always a duplicate in this list. So you don't have to worry about length checks, null checks, stuff like that, just to move things along. And the idea here is, as you iterate through that array, I want you to return me the first duplicate found. So in this array, for example, this 1, 2, 3, 4, 5, 6, 1, 3, or console log output or whatever would be 1.
Great. And if that one wasn't there, let's say we have the same array except for the first one here, then it would be 3, correct?
Correct. Yep.
Great. All right. Well, you answered most of the basic questions I have, which is, is there going to be anything other than integers in this array? And is it always going to actually be filled, which is great. I don't have to worry about a false statement, right? We're always going to be, well, I guess if there is not a duplicate, or we're saying there always is a duplicate, right? We don't even have to worry about that.
Exactly.
Great. So we don't have to worry about a false. So I can think of several different ways to do this. One would be basically just running nested loops, right? And then setting up 2 different indexes and running through and basically trying to match each one right along the way. And the first index would be matching with the second index. And then whenever it's found, then we would just return that number. Do you want just the single number returned, the pair of the numbers, the index of the number? What do you want returned?
Just the duplicate. So in that case, it would be 1. Yep.
Okay, great. Return the duplicate singular. So we need to actually take those values. Okay, cool. The other way I can think of is if we basically add all of our numbers to a hash map, and then check through that hash map, and basically if basically when we're adding them to a hash, we could set a value to 1, and if the value ever goes to 2, then we would return that basically if this already exists, right? So that, I don't think I'm explaining that well, or articulating that well, but I think that makes sense in my mind, where basically we could return the first time we would ever increment, or we've already found that item in this hash map. Does that make sense?
Yeah, no, it totally makes sense. So the two solutions you presented, one was nested loops. Mm-hmm. One was create a hash map. If we were to go with the first one, do you know the complexity of that?
Yeah, I think it would be O of n squared.
Yeah.
Because we've got the nested loops. So, and we're running it on the same input. So we're always going to, basically, no matter what the first one is, we're always going to have to run that again. So O of n squared.
Yeah, exactly. Yeah. So if it was O n squared loop and we decided that we wanted to do that implementation, what if this list was like 6 million records?
It'd be tough.
Yeah, right. It would take a long time.
Yeah.
So the hash map, if you did that, do you know the complexity of that?
I think it would just be O of n And the way that I'm thinking of it is, as soon as we got to a duplicate, it would kick out, right? So it would return. So we don't even have to actually go all the way through it. But I think if we're O of n, we're assuming for the worst case or the average case, right? So I think it's O of n.
Yeah. Like essentially, no matter, like if the last two were your duplicates, like you would have to go through that whole list no matter what,
Yep.
right? So yeah, so in. Yeah, cool.
Yeah.
Which one do you prefer?
I'd rather the hash map.
maps are not, they're not inherent in JavaScript too. So that makes things a little different. I've had people do this in Java where they have hash maps. You can actually do this in Python, I think in one line of code. I've had that happen before. JavaScript's a little just an interesting beast because those data structures don't exist. You have to create them.
Right. I feel this is actually interesting. I feel like I've heard that said before, and I don't actually know what that means, because when I think of, I've been trying to clarify, because when I think of hash map, like the way I would write this is let result equal, or whatever we want to call this map. I just make it as that, and then I would just populate it using a for loop, right? So what do you mean by it's not inherent in JavaScript? Like I can get that functionality out of it by just doing that.
So in Java, they actually have a type. Yeah. So you're constructing the hash map manually, but like in Java, they have a type of hash map. They have dictionary, things like that, right? There's no inherent type of hash map in JavaScript. You're creating it. You're creating an object of key value pairs.
Yeah. Okay. Got it. Yeah, I have been trying to clarify what I say hash map versus object, and between using Ruby and JavaScript sometimes is fun, because I think in Ruby everything's kind of an object, and I've been trying to get more specific, but that makes sense. Okay, so I could pseudocode this, but basically my goal would be to create the function that takes an array of numbers, which we always know are going to be positive. Create our map object like below, right? And then create a for loop to move through array of numbers, and then we want to make an if check to see if item exists in hash map. If it doesn't, we want to do an if check to see if the item does not exist in the hash map. If item exists in hash map, if it doesn't, then create / add it, else return. I think exactly what we're returning. We would be returning the array index, which should call
the item that already exists, right?
Yep. Array index. Great. That makes sense to me. Does that make sense to you?
Yeah, sure does.
Okay. Great. So let's get rid of those. What do we want to call this? This is find dupe. And we want to pass in our Am I selecting all that? No.
Yeah, you are.
Oh, okay. Sorry, I'm sitting. I got a let's say a cheap janky desk setup where I'm sitting down right now, so my screens are slightly tilted up, and everything at the very top gets a little fuzzy. Okay, const find dupe equal input numbers. Trying to get in the habit of using arrow functions, so you get to see my new fancy arrow functions.
Nice. Welcome to the future.
Yeah. I used to be scared of them, but I'm trying to embrace it. For all the 2 lines of or 8 characters, it's going to save me every time I make a function.
Yeah.
Okay, so we create our map, create our for loop index. We're going to start at 0. We're going to run our index as long as input numbers dot length, right? Index was equal 1. So then we want an if check. So I'm following my own logic here. So if map input numbers index. So if that doesn't exist, then map input numbers index equals 1. Else return put numbers index. So I think if my syntax isn't messed up, I think I've done what I was trying to do. So for example, if we take 1, that's going to be passed in, it's going to be the first number here. 1 does not exist, so then it's going to be created as map input number index equals 1. Same would happen for 2, same would happen for 3, 4, 5, 6. And then when it gets to 1 again, it would see that that does exist already. So it'll kick to the else, and then it will return input numbers index, which should be 1. That makes sense to me. Does that look correct to you?
Yep.
Okay.
Run it.
Great. Nice.
1. Good
Cool.
job.
And like we thought, if that 1 wasn't in there and we did the same thing, 3 would kick out. Yeah. Okay. Great.
Cool. All right. So as I talked about in the previous segment, what I like to do with this problem is depth, right? So we got there. We got there with an Owen solution, which is great. We didn't do the brute force, which was, again, like I said last segment, sometimes it's okay to do brute force to get to an answer. I've had plenty of people move on to the next stage just by doing the Owen squared loop. So my question to you, if we go back, there's 2 questions I have to your code. 1, there's a micro optimization we can make. So again, if this array was 900 million characters long or something, right? Do you see the micro optimizations? There's a couple actually. We're repeating some things over and over. I'm assuming you know what dry is.
Yes. Dry code, I mean, we don't want to duplicate. I don't actually remember what it stands for, but basically try not to duplicate things or rewrite the same code.
Yeah. Don't repeat yourself.
Yeah.
So we're accessing, yeah, exactly. We're accessing that array 3 times. Yeah. So that's a micro optimization. We don't have to do it, but the idea here is like, can you look at your code and say, oh, there's something I could make better? And obviously with prompting, right? Like I'm not sitting here, and then you can also do some other micro optimizations. They probably don't really mean a ton. You can put length in numbers.length in a variable as well, like a const. And I think that's like the most you can do here.
Yeah.
But Go ahead.
Just say for readability, that would be like probably the clearest thing. So looking at this, I mean, I think would make sense to most folks, but it's definitely not pretty, right? Versus
Right.
map, current number, or whatever you want to call it, and this just being length, right? So that makes a lot of sense.
Yeah. So somebody probably, ding you in code review on that one. So the second question I have, the follow-up question, like, if we have time, is let's say you're working with a finite, like, again, this is all hypothetical. We don't think about these things or even necessarily have to deal with them, but also just an important problem solving aspect. And the secondary question, follow-up question I have is, once we get to a right answer, is say I have 8 megs of RAM available on my machine.
Mm-hmm.
And the list that I'm sending you is 6 gigs big. Wait, I have 8 gigs of RAM on my machine, and the list that you're getting in is 6 gigs. How does that change your solution? Could you even do this given those constraints?
Good question. I don't know enough about how stuff is stored, but to maybe answer that fully. But what I would assume is that what I'm doing here, right, is I'm remapping this entire list. So if it's 6 gigs and I only got 8, it's probably going to take up let's say 12, right? If that's how that memory would work correctly. So that probably wouldn't work. It might. So I think that's, correct me if I'm wrong, but is that when we're getting into space complexity?
Yeah. And I'm not a huge big O guy, but yeah, right. So now we have a problem, right? Again, if those last 2 numbers are the duplicates in your list, you've just created a 12 gig problem, right? Your computer is going to start on fire, essentially.
Yeah.
So how could we solve it? Like, we obviously can't use the data structure, or we can't use an additional data structure. Is there a way we can solve it without using the map?
Yeah, we'll I guess this is interesting. I'm going back to nested loops. I think that actually has a smaller, again, correct me if I'm wrong, but would that have a smaller space complexity? Because we're not actually recreating anything. We're just taking the same list and then running through it twice. So time-wise, it might take longer, but the actual space does not increase when we're running through it, right?
Right. But, say this is something like, again, these are all hypotheticals, but like, say that we can't, for the time complexity, we can't take forever to process this either.
Okay. So we gotta have both.
Whatever.
Yeah. We gotta have both that are at least decent. Okay. I'm trying to think if there's a recursive way to do this. I don't know if I know of one and if that would help, but in my head, maybe that's a potential solution. But I worry if it's a recursive solution and we have that many things, it might just, we got a million little recursive functions running, which might have the same issue as anything else. Is that
Are there any, like, given the rules of the problem, right? We always know it's positive integers. We always know it's going to have a duplicate. Is there anything on the array prototype we could use that would help us?
Yeah. I mean, if we could call a method on it, I mean, a dot find or a dot duplicate or something, or array dot includes, right? There may be ways to kind of make those work with this.
Yeah, even simpler than. Again, think of the constraints. They're always positive integers.
If they're always positive, I'm trying to think if we could just pass in that. I'm trying to think of if this, just if we passed in like a array, array 1, if that would. No, I don't. Yeah, I don't know.
This is a really good example of where engineers tend to overcomplicate everything. And trust me, like I'm the same way. Like I'm no different than the next engineer whoever did this stuff. But if we think about it, really what we could do is we could just sort this array in place, right?
Mm-hmm.
And then you just go pair by pair. You never have to build another data structure. You're certainly going to just like, the sort method is plenty fast.
Yeah.
And then you just go pair by pair. Does 0 equal 1? No. Does 1 equal? And then once you find it, you're done. Just exit out of the loop and you're done.
Yeah, that makes sense. Nice.
But like I said, we always tend to complicate things when we first think of it. You went to regression, or not regression. You went to recursion.
Yeah.
And I was like, I don't know. Like maybe you could, if you want to think through recursion. But I typically like the human brain doesn't understand recursion. I still to this day like find it to be the most confusing thing. But I think usually when I give the hint of like, is there any array methods, the exact same thing happens. Well, you could use includes, maybe you could use find, maybe there's a way we could reduce, but nobody ever goes to the easiest thing, and that's just sort the damn thing and go one, pair by pair until you find it.
That makes sense.
But you moved on to the next round. Good job.
Nice. I'll take it.
And I think you did a great job, as people are watching this and like using pseudocode. What am I going to do? Think out loud, asking questions, and then writing it, coming up with a couple solutions, talking about what you think is the right solution or the better solution, right? And that gives me an opportunity to pry, right? And say, well, what do you think the better solution is? What if you went with this solution? What if the list was 9 million items big? Things like that. So this is like the problem I use. Like I have used this for a long time now, and I've had a lot of people get through it, and I've had a lot of people provide a ton of positive feedback on it. So it's a very simple problem, right? And this is something that's pretty relevant to things that we have to do every day. I mean, especially in JavaScript, I'm parsing arrays all day long, maps, reduces, all that stuff, right? So I don't know. I've always found it to be relevant and fun, and there's always varying levels of skill, like people immediately go to hash map, or they'll do the n squared and then they'll get to hash maps. There's like a lot of fun and like just getting to the better solution and seeing people like the aha moments and things like that. So
yeah, and I think this is a good example of a problem where if you have, it's common enough problem, right, that people ask that if you have some understanding, at least a base understanding of it, then when someone asks those questions about what happens if we have to do this, right? Or, you could have said half of them are, we have to account for non-integers, right? And that's a whole different problem, really, right? So I think it's a problem where you have some understanding of it, it's helpful, but then people can, like you said, throw stuff in to make it much more complicated, really to almost the nth degree, right? Where you can add enough stuff where this problem could stump most people, right? If you really add some spice to it. So I like it.
Yeah.
The last thought that comes to mind.
There's a final, I was going to say there's a final step to this. I rarely ever get to it because the solution is still like really difficult, but the idea, and like sometimes if somebody's like really good and gets that far, I'll be like, what if the data is read only? Like you can now not sort it at all. Right. So that gets into like a really complicated like solution. I've only ever, I think, gotten there 3 times with people. And even to this day, I still have no idea how you would solve that. But it's a fun conversation to have. Like we don't deal with like, the idea is like that data comes in a CD-ROM or something, right? Like you cannot manipulate it at all. So now what do you do?
Yeah.
And I think,
interesting.
I think again, and whoever's watching this can correct me and call me an idiot if they want, I don't care. Is to split the list somehow, divide and conquer, and until you get down. But I don't know. That's some crazy talk.
Yeah, I think that's a good example though of in an interview often like if you don't actually have a solution for that, right? Especially off the top of your head, if you're asking that of someone, I think often people in interviews go, I have to have the exact answer for them, right? Or know this. A lot of times you're having a conversation of how would you do this, right? Or how would you solve this? And interviews are often trying to push to the edge of your knowledge and then go, okay, well, that's where the edge is, right? And I think that's the almost that is the interview, a lot of times, like hit the hardest point, and that's where people go, okay, this is what we're actually trying to see, is how do you solve problems you don't have an immediate answer for, right? Because that's what software engineering is, right? Most of the time is we have to think of a solution to this problem that all I have is, hopefully a little bit of something to go on a ticket, right?
Yeah, exactly.
Yeah. The only other technical thing that came to mind was, have you ever seen someone solve this with a set? Basically passing individual numbers into the set, and then I'm assuming you could kick out of it maybe if there's a duplicate, because you could only have the same or each number in there once in a set, right?
Oh yeah. No, I don't think I've ever seen anyone use a set. You could. Those are new. Yes, 6 things, right?
Yeah, I don't see a ton of problems with people using them all that often, but that's something that is interesting. And I don't think would be the first thing that would come to mind, right? But it was the only other thing when you said, like, oh, is there another way to do this? And I was like, a set, but I think it runs into the same problem this runs into, right? Is you're basically building it as you loop through it. And if you had a space complex or a space issue, then it would have the same constraints.
Yeah.
Cool. All right. Well, anything else to add before we wrap up?
No, nothing else to add. I love that you're doing this. I think it's fantastic. I can't wait to share it with Balto, so they can sort of get, an idea not only of like, hey, this thing exists and subscribe, but also like my philosophies on hiring and interviewing and things like that. Yeah. I mean, I'm happy to, find me on LinkedIn. Happy to talk about these things. Yeah, I don't know. And thank you so much for the opportunity to talk with you, and great catching up, obviously, and good luck on the rest of your road trip. And
yeah. And thanks so much, obviously, for being here. I'm in Balto is hiring, I'm assuming.
They are hiring. Yeah, I have 4 openings on my team looking for senior React and senior Python developers. We're growing. We're just growing like crazy. We have an office here in Chicago. We're 100% remote friendly. Headquarters is in St. Louis. Like I said, it's a fantastic company, great people, awesome product. Yeah, we're hiring. Be on the lookout. I'll be posting on LinkedIn about my openings probably in the next few months, I would say. Few weeks, probably, actually.
Cool. Well, folks, find Patrick on LinkedIn and Adam, and send him a message about Balto openings. And thanks so much. It's been a blast.
Yeah. Thank you, Taylor.
Thank you for watching the technical interview portion of the Professional Technical Interviewee. If you want to tackle this interview question, you can find it at github.com/professional technical interviewee. New episodes are released on the first 4 Thursdays of each month. Find us on YouTube at youtube.com/Taylor Dorsett, or on Apple Podcasts or Spotify. Make sure you subscribe so you don't miss out on new episodes. And remember, keep practicing.